So, let xy be a discrete random variable with the joint probability mass function Pxy xi yj for I is equal to 1 to like this and j is equal to. So, basically this range of Rxy may be finite or countably infinite, but we are representing like this, I is equal to 1 to this, j is equal to 1 to this. Then the conditional probability mass function of x given, suppose this y taking some value. So, here yj is fixed some value, it is given that y observed yj given yj is defined as. So, how we can define this probability that, so probability x given y, xi given yj, it is defined at conditional probability mass function we are finding. So, probability that x is equal to xi given y is equal to yj. So, yj here fixed and we are taking different values xi, it can take what is the probability. Though by definition this is x equal to a given b is a intersection b by probability of b. So, intersection we write here as a comma, y give equal to yj by probability of y is equal to yj. So, this is nothing but this is by definition this is joint probability mass function by the marginal probability mass function of. So, here for I is equal to 1 to like this and j is equal to. So, j here fixed, but it may be any value it can take. So, that is why we can write like this. So, now here this is important that for a given yj, for j can be any value, we are finding the probability mass function. So, it will be a probability mass function. So, the properties of the probability mass function, it has to be satisfied. So, what are the properties? So, properties is that summation that p x given y, particular fixed value xi given yj, whenever you are taking the sum over I or xi, you can say like all variable of xi, this should be is equal to 1. So, here it should be very clear that this is not the sum of yj here, it will, if we vary yj fixing xi, this may not be equal to 1. This is that particular values of y for yj belongs to range of y, we can say, or for we have written j is equal to, j belongs to 1 to this. So, if it is finite 1 2 dot dot some value n, so otherwise it may be infinite also. Now for a particular values of j, this sum will be equal to 1, and this is a probability mass function. Oh, this is a second property, I think it is written here, second property here, and first property is that this is a probability. So, probability will be always x given y, xi given yj, this will be less than equal to 1, greater than equal to 0. So, these properties are given the other way. So, conditional probability of x given yj I have written here. So, similarly it can be defined probability conditional probability of y given x. So, the conditional probability so similarly the conditional probability mass function of y given x is equal to some particular values xi is defined as probability that we y given x, yj given xi. Here xi is some fixed value, we are finding the conditional probability mass function. This is by definition x is equal to xi intersection y is equal to yj by probability of x is equal to xi. So, here assumption is that because it is a probability mass function, it is the range of x. So, assumption it will be non-zero, x is equal to xi. So, it can be represented as Pxy xi yj by Px of marginal probability mass function. This is joint probability mass function. For j is equal to any value, and particular value is I, any value 1, 2, like this. So, now these properties are discussed because it is a probability mass function. So, it is probability. So, this will be must be less than equal to 1, greater than equal to 0. So, it will satisfy all the properties of probability mass function, and like if you take the sum of y given x here for a particular value of xi, if you fix this xi, and if you take the sum over yj, this should be equal to 1 for sum I belongs to 1, 2, like this. So, this is given here, you can see that. So, this so here this condition also it is written because it is a probability mass function. So, this part has to be not non-zero, it will greater than 0. So, similarly here also this part has to be greater than 0. So, here also this part has to Px of xi has to be greater than 0, otherwise this will be undefined. So, this is concept of conditional probability. So, let us discuss if you have understood it, the conditional probability mass function, how it is defined. So, it will be more clear when we will do some numerical examples. So, these examples are given, some example here we will do. So, the joint probability mass function of a bivariate random variable xi is given by this function. So, joint probability mass function k xi square yj, xi is equal to 1, 2 and yj is equal to 1, 2, 3, 0 otherwise. So, let us write down this, the joint probability mass function the joint probability mass function of xy of a bivariate discrete random variable xy is given by Pxy xi yj. This is equal to k xi square yj whenever xi is equal to 1, 2 and yj is equal to 1, 2, 3. So, I think these are the values, xi is 1, 2 and yj is 1, 2, 3 and 0 otherwise. So, k xi square yj, xi is 1, 2 and yj is 1, 2, 3, k xi square yj and 0 otherwise. So, this will be 0 otherwise. So, now k is a constant. So, where k is a constant, find the values of k. First we have to find the values of k. So, similar approach we will take. So, we have done similar kind of problem earlier also. So, we will use the properties of the probability mass function. So, first of all it has to be greater than equal to 0 and we see that k has to be greater than 0 and otherwise it will be 0 and other property like sum has to be 1 will not be satisfied. So, k has to be greater than 0. Second property is that if you take the sum of all xi is equal to 1, 2, 2 and yj is equal to 1, 2, 3, Pxy of xi yj, that has to be equal to 1. So, now if you write k into, so xi is equal to 1 and y is equal to 2. So, then k into xi square 1. So, 1 square into 1 plus 2 square into 1 plus 1 square into 2 plus 2 square into 2 plus 1 square into 3 plus 2 square into 3. So, this is the total sum. So, it should be equal to 1. So, now let us, we will just simplify it this 1 plus this will be 4 plus this is 2 plus 4 into 2 8 plus 1 into 3 3 plus 4 into 3 12. This is equal to 1. So, finally, what we are getting k 5 plus 7 15 18, this is 30, this is equal to 1. I hope this is correct. 15 and 12 plus 2 14 plus 1 15 plus 15 30. So, which implies k is equal to, finally what we got, we solving this equation 1 by k is equal to 1 by 30. So, then our probability mass function now, what we got, Pxy of xi comma yj, this is equal to 1 by 30 xi square yj whenever xi is equal to 1, 2 and yj is equal to 1, 2 and 3 and 0 otherwise. So, this is the probability mass function we found. Find the marginal probability mass function of x and y. Now, we have to find the marginal probability mass function. So, how we will find the marginal probability mass function? So, by definition, if you want to find the marginal probability mass function of x is, how we will find? So, we have to find x of xi. So, xi can be 1 or 2. So, this is equal to yj will take the sum of the other variable, yj is 1, 2, 3, pxy of xi yj. So, this is nothing but 1 by 30. So, then k is 1 by 30, then xi square into 1 plus xi square into 2 plus xi square into 3. So, this is nothing but, so now since this is this value will be for xi is 1 and 2, otherwise this value is 0. So, so we can write for xi is belongs to 1 and 2, otherwise this value is 0. So, xi square, so 2 plus 1 6 xi square by 30. So, this is nothing but xi square by 5. So, we have to write properly the probability mass function. So, this probability mass function, marginal probability mass function, the marginal probability mass function of x is given by px of xi is none. So, we have to write the total domain. So, xi square by 5, whenever xi is 1 and 2, this is 0, otherwise this is 0. Similarly, we will find the marginal probability mass function of y is given by p of yj. So, this is equal to sum of, we have to take the sum of xi is equal to 1 to 2 pxy of xi yj. So, here we will take the sum of the other variable fixing yj. So, now this will be for yj belongs to 1 or 2 or 3, one, 2 or 3, py of yj can be written summation of xi. So, this is 1 by 30. So, because otherwise this value will be 0 for any other values of yj, for yj belongs to 1, 2, 3, 1 by 30 xi square yj. So, 1 by 30 into yj xi square. So, yj it will common, then xi square 1 square plus 2 square yj, xi square yj 1 square yj plus 2 square yj. So, finally, we are getting this 5 yj by 30. So, this is 5 yj by 30. So, yj by 6, So, we will write properly this value. So, finally, what we got? P of yj, the marginal probability mass function of y is P of yj. This is equal to what we got? Yj by 6, whenever yj belongs to 1, 2 and 3, or we can write like this, yj is equal to, for yj is equal to 1, 2, 3 and 0 otherwise. So, we have to properly write in this way, where it is non-zero and what is the value, and where it is actually equal to 0. So, this is the marginal probability mass function. So, now what are the next question? Are x and y independent? So, x and y independent, how we can find? So, for suppose if x and y, xi and yj are independent, so then P of xy, the joint probability mass function yj it will be Px of xi and P of yj for any xi and yj values. So, now you can see that if xi belongs to 1, 2 and yj belongs to 1, 2 and 3, then Pxy of xi yj is nothing but 1 by 30 xi square yj. That can be represented as xi square by 5 into yj by 6. This is nothing but Px of xi into Py of yj. So, you can see that Px of xi is xi square by 5 and Py of yj is yj by 6. Hence, for if xi does not belongs to 1 and 2 or yj does not belongs to 1, 2 and 3, then Pxy of xi yj will be 0, which is equal to Px of xi into Py of yj. So, because if xi does not belongs to 1, 2, then the left hand side this joint probability mass function will be 0 and Px of xi will be 0, and if yj does not belongs to this, then P of yj will be 0 and left hand side also will be 0. So, one of them will be 0 marginals. If both does not belongs to this point, then both will be 0. So, for all these situations this will be equal. Hence, Px of xi yj, we found that Px of xi into Py of yj for all xi and yj values, for xi and yj. So, x and y are independent random variable. So, implies x and y are independent random variable. X and y are independent random variable. Now, what is the next problem? So, x and y independent. Find the conditional probability mass function of y given x, yj given xi. So, we have to find the conditional probability mass function and then we can compute those values from the probability mass function also. So, what will be the conditional probability mass function? So, by definition, the conditional probability mass function of x given some value y is equal to yj is, so P of x given y, xi given yj. This is P of xy, xi yj by probability of, by definition. Now, note that this will be non-zero when yj belongs to 1, 2 and 3. So, this is nothing but if this is, otherwise this will be 0, it will be undefined. So, for yj belongs to 1, 2, 3 only we can compute this value, and otherwise this upper part also 0. So, this will be by we can define as 0 because it is a probability mass function. We have to define the other values, we will define as 0. So, then Pxy of xi yj is nothing but 1 by 30 xi square yj by Py of yj, we know that. What is Py of yj? This is yj by 6, yj by 6. So, this is nothing but this yj it will cancel. So, xi square by 5. So, we can write down properly, like the conditional probability mass function is defined by xi given yj. This is, so xi square by 5 for xi is equal to 1 on 2 and yj has to belongs to, it will be yj has to be, it is given 1, 2, 3, one of the value, then this is the probability mass function. 0 for any other case, this value is 0. So, either xi does not belongs to 1, 2 or yj does not belongs to in the 1, 2, 3. So, note that this is the marginal. So, this is same as the marginal probability mass function of xi. So, conditional probability of y, because it should be, because x and y are independent random variables. So, conditional probability should be equal to, so what is y taking some values or not, the probability of x taking some value, it should not depend on the what the value y is taking the value. So, conditional values of y, it is given or not, it does not matter. So, that is the independence. So, similarly we can show that the conditional probability of y given x also same as probability of y. So, that we will discuss again how conditional probability should be same. So, now the conditional probability mass function of y given x is equal to suppose some value xi. So, for defined as px xi yj, sorry, is probability of y given x some value yj given xi. Xi is some fixed value. By definition, pxy of xi yj by of px of xi. Note that xi has to be belongs to 1 2, otherwise this px of xi is equal to 0. So, it will be undefined. So, this is by definition, this is, so this is xi square yj and px of xi. So, this is joint probability mass function, 1 by 30 square xi square yj, and px of xi is xi square by 5. So, this is xi square by 5. So, then this is cancelled, then this is yj by 6. So, hence the joint conditional probability mass function can be written. Actually, we have to properly write it. Xi is nothing but yj by 6 whenever yj is 1, 2 and 3, and given condition xi can be some value, it can take 1 or 2, this will be 0 otherwise. So, note that this is actually, this function is not depending on xi, whatever the values of xi or 1 or 2, this value same, it is only dependent on yj only 1, 2, 3. So, which is nothing but y of yj. So, this is the marginal probability mass function. So, conditional probability mass function does not depend upon actually the because the x and y are independent. So, the conditional probability mass function of y is same as the marginal probability mass function of y. So, this is coming from this relationship also. So, if x and y are independent, so from the example what we got in general are independent random variable. So, by definition pxy of xi yj, this is product of px of xi into p of yj. Now, the conditional probability mass function of x given y is equal to yj is x given, suppose xi given yj. So, definition is px of xi yj by p of yj. Now, since they are independent, so this condition is true. So, we can write px of xi p of yj by p of yj. So, then this is cancelled, assuming that p of yj not equal to 0. So, then this is nothing but px of xi. So, that is why this is equal to px. So, this is equal to the marginal probability mass function. Similarly, it can be shown that p of y given x yj given xi, by definition this is pxy of xi yj by px of xi, this is definition, but x and y are independent. So, this is nothing but px of xi into p of y of yj by px of xi. So, this is cancelled. So, p of y yj. So, if they are independent, this conditional probability mass function we need not to compute, we just can directly say that because they are independent. So, the conditional probability mass function should be equal to their marginal probability mass function. So, now the last problem we will apply this result, we will not compute. So, by using the definition, because it is asking probability of y given equal to 2 by x given x equal to 2. So, probability of y is equal to 2, probability of y is equal to 2 given x is equal to 2, because we have seen that x and y are independent. So, this will be equal to nothing but y is equal to 2 only. So, we need not to compute the a given b, a intersection b, all these things. So, and conditional probability mass function, so this is nothing but y of 2. So, the probability mass function of y, what is that? Probability of yj by 6. So, this is p of yj is yj by 6. So, yj by 6 just yj is 2. So, this is 2 by 6. So, this is nothing but 2 by 1 by 3. So, similarly, if you want to find the probability that, what is the probability that x equal to given x, probability of x equal to 2 given y is equal to 2. So, this is probability of x is equal to 2 given y is equal to 2. So, this is nothing but, because they are independent, x and y are independent. So, this is x is equal to, this is nothing but the probability mass function of x evaluated at 2. So, probability mass function of x is given here, xi square by 5. So, that we will write here xi square by 5. So, this is 2 square by 5, xi here 2. So, this is nothing but 4 by 5. So, this is the one problem we discussed using the conditional probability mass function. So, I hope you are following and you understand the concept of whenever x and y are discrete random variable, how to find the conditional probability mass function and their properties, and how to check their independence also with respect to conditional probability mass functions, and how to compute the respective probabilities also, what we discussed in the numerical examples. Next, we will discuss what will happen if x and y are two random variable, those are continuous random variable, and in that case we need to discuss, we already discussed that joint probability density function. So, here we will discuss conditional probability density function, how it is defined and what are the properties and how we can compute the related probabilities with respect to the conditional probability density functions for the continuous bivariate random variable cases.